In question number 1, we have our x as a random variable, and that random variable is described by uniform probability distribution. Our c is 30, d is 70, and we are asked to find the probability that our x is greater than 50 and less than 70. So at first, let's start with finding a function that describe our uniform probability distribution. And to find that, we have f of x equals to 1 over d minus c. So this is 1 over our d is 70, c is 30. This is equals to 1 over 40. So our function is 1 over 40. Now next, let's go ahead and draw a graph for this uniform distribution. So here we have a function f of x equals to 1 over 40. So we draw a horizontal line, okay, at 140. Let's say this point is 1 over 40. Our c is 30 and our d is 70 here. So we draw horizontal line at 1 over 40 from 30 to 70. Okay, so this is the uniform probability distribution. We draw vertical line at 30, we draw vertical line at 70. So here we have a rectangular shape, okay, and this is our uniform probability distribution. In part B, we are asked to find probability that our x is in between 50 and 70. Now let's go ahead and locate our x. So this horizontal axis is our x, vertical axis is our f of x. 50, 50, so this is, so let's say our 50, let's say our 50 is here, and we want to find the probability from 50 to 70. So let's draw vertical line at 50. Okay, here finding a probability means is same as finding the area under the curve from 50 to 70. So we have the curve from this point, so this is our curve from 50 to 70, and we are interested in finding the area under this curve. Okay, and that area is the probability that our x is in between 50 and 70. So this is a rectangular shape, and we know how to find the area of rectangle. So this height is 1 over 40, and next this width, so this is 70 minus 50, which is 20. So our probability that x is greater than 50 and less than 70 is equals to the area of this rectangle, and the area of rectangle is 20 times 1 over 40, and this is 20 over 40, which is equals to 0.5. Okay, the next question, we have part C. In part C, we are asked to find the area, sorry, we are asked to find the, so this is part B. Okay, in part C, we are asked to find probability that our x is greater than equals to 64. We are using the same function, same distribution. So let me go ahead and draw the same graph here. So this is our x, this is our f of x. We have 1 over 40 here. Our c is 30, d is 70, and we have this graph. We have this rectangular shape. Now in part C, we want to find the probability that x is greater than 64, okay, greater than or equals to 64. So let's go ahead and look at 64. Let's say our 64 is here, okay, and draw a vertical line at 64. Now we look for the graph for the x value which is greater than 64. So greater than 64 means the graph on the right of 64. So this part, okay, we are interested in finding the area under this graph. So we want to find the area of this rectangle, and very similar to previous one, this height is 1/40 and this width is 70 minus 64. 70 minus 64 is 14. Okay, so the probability that our x is greater than equals to 64 is the area of this rectangle, which is 14 times 1/40. We have 14 times 1, 14 divided by 40, and this is equals to 14 divided by 40, 0.35. So 0.35 is the probability that our x is greater than or equals to 64. Next, let me go ahead and do number F. So in number F, we are asked to find, it's very similar probability that our x is greater than equals to 50.5 and less than equals to 56.5. We are using the same graph, so let's go ahead and draw the rectangle. So this is our f of x. Let's say this is 1/40. So this is 30, this is 70. It's the exactly same graph, okay? So we draw a rectangle here, the graph uniform distribution. We will locate 50.5 and 56.5. Let's say 50.5 is here, 50.5 and 56.5 is here. We draw vertical line at 50.5, vertical line at 56.5. We want to find the probability that our x is in between these two numbers. Okay, so we look for the graph in between these two numbers, and this is the graph, okay, in between these two numbers, and finding the probability is same as finding the area under this graph. And here we have a rectangle, so this height gonna be 1/40, and this would be the difference of 56.5 and 50.5, which is 56.5 minus 50.5, so 6. This is 6. So this probability is equals to the area of this rectangle, green rectangle, which is 6 times 1/40. This is 6 times 1, 6 divided by 40, and 6 divided by 40 is 0.15. Okay, so this is the probability that our x takes a value between 50.5 and 56.5. Okay, now let's get to the next one. So next is number 3. In number 3, we have a uniform distribution. Our C is 3, our D is 11, and we have to complete A up from A to F. The first, we have to find the function. Okay, so the function, since we are talking about uniform probability distribution, our function f of x is always 1/d minus c. 1/d is 11 minus c is 3, and this is 1/8. So this is our function is 1/8. So 1/8, and our x is in between 3 and 11. The next, we are asked to find the mean. Okay, so mean for the uniform probability distribution mu is c plus d divided by 2, and c is 3 plus 11 divided by 2, which is 14 divided by 2, and this is 7. So this is the mean for our uniform probability distribution. Next, we are asked to find a standard deviation. So standard deviation sigma is, so let me go ahead and check the formula for our standard deviation for a uniform distribution. Okay, the formula to find the standard deviation sigma is d minus c divided by square root of 12. D is 11 minus c is 3 divided by square root of 12, and this is 8 divided by square root of 12, and this is equals to, so we have 8 divided by, so 8 divided by square root of 12, square root of 12, that is 2.3. So 2.3 is the standard deviation. Next, we are asked to find the probability. Excuse me. So in part C, we are asked to find probability that our x is greater than equals to mu minus sigma and less than equals to mu plus sigma, or this is also this is, we can also interpret this as a finding a probability that our x is in between x is within one standard deviation, okay, of a mean. So this is our one standard deviation. So we want to know what is the probability that our x is within that one standard deviation. Now let's go ahead find these values. So this is, we have p as it is. We know our mu is 7 minus sigma is 2.3, less than equals to x less than equals to 7 plus 2.3. This is probability. So 7 minus 2.3, so 7 minus 2.3, that is 4.7, less than equals to x less than equals to 9.3. So in part C, we are asked to find the probability that our x takes a number greater than equals to 4.7 and less than equals to 9.3. Okay, for that we need uniform distribution, and our uniform distribution is rectangular shape. So this is our f of x. We know our f of x is 1 over 8. So we get a straight line starting from 3 ending at 11. So let's say this is 3, this is our 11, and this is our 1 over 8. So we draw a horizontal line here, we draw a vertical line here, and we get a rectangle. We want to find our x is in between 4.7 and 9.3. So let's go ahead and locate 4.7. Let's say this is 4.7 and this is 9.3. Okay, we draw a vertical line at 4.7, vertical line at 9.3. Now this is the graph. Okay, this is the graph in between 4.7 and 9.3. Finding probability means we are finding the area under this graph. It means we are finding the area of this green rectangle. Okay, so this height is 1 over 8, and this is, so here so this distance is 9.3 minus 4.7, 9.3 minus 4.7, that is 4.6, 4.6. Now this probability is equals to the area of this rectangle, which is 4.6 times 1 over 8, which is 4.6 divided by 8, and this is equals to 0.6 575. Okay, so this is the probability that our x is within one standard deviation of a mean. Now in part D, we are asked to find our probability that x is greater than 5.88. So in number D, we want to find probability that our x takes a value greater than 5.88. So at first you draw the same uniform distribution. So we have a horizontal line here starting from 3 ending at 11. This is our 1 over 8. Now at first we locate 5.88. So let's say this is 5.88. Draw a vertical line at 5.88. And we are interested in x greater than 5.88. So greater than means we are interested in a graph on the right of 5.8. So we want to find the area under this part of a graph, and which is same as finding the area of this rectangle. So this height is 1 over 8. The next this distance is 11 minus 5.88, so which is 5.88 5.12. So this is 5.12. So our probability is 1 over 8 times 5.88, and this is 5.88 divided by 8. This is equals to, sorry, not 5.88. So our width is 5.12. So let me correct that. 5.12. So 5.12 divided by 8. The probability is 0.64. So this is for part D. In part E, we are asked to find the probability that our x is in between 5.2 and 7.8. So let's draw. So for part E, we draw the same distribution, uniform distribution. This is x, this is f of x, this is 3, this is 11. This height is 1 over 8. We want to find the probability that our x is in between 5.2 and 7.8. So at first we locate these two numbers. 5.2 let's say it's here, 7.8 somewhere here. So we draw a vertical line at these two numbers. So at first we want to locate the graph between these two numbers. So from 5.2 to 7.8. So this is the graph, and finding probability means finding the area under this graph. Okay, finding the area of this green region. So which is rectangle. So this height is again 1 over 8. This distance is difference of 7.2 and 5.2, which is 2. So the probability is 2 times 1 over 8. So this is 2 over 8, 1 over 4, which is 0.25. So this is the probability that our x takes a number between 5.2 and 7.8, which is 25%. Next, in number F, we are asked to find the probability that our x takes a value less than 3. Now here, our rectangle, our x takes a value greater than 3, right? So if we look at one of these distribution, so here our x is from 3 to 11. Okay, there is the x does not take any number less than 3, and it does not take a number greater than 11. So the probability that our x taking a number less than 3 would be 0. And in the similar way, if you are asked to find probability that x takes a number greater than 11, it is again a 0. Okay, this is for part F. Okay, the next one here, number 4, our x is normally distributed random variable. Okay, whenever you see a normally distribution, at first you start with drawing a bell-shaped curve. So we have this bell-shaped curve, you locate your mean. Our mean is 10. Okay, mean is 10, standard deviation is 2. In part B, we are asked to find probability that x takes a value less than equals to 6.5. Okay, so let's look at 6.5. So let's say 6.5 is here. You draw a vertical line here and here. Okay, so we want to find the probability that x is less than 6.5. So less than means everything on the left. So we are interested in finding an area of this region. Okay, so we are interested in finding the area under this part of a curve. Now since this is a normally distributed random variable, we use a normal table. Okay, to use normal table, we have to convert, we need a g. Okay, but we are given x, so this is our x. So let's convert each of this number into g. So the formula to convert into g is x minus mu divided by sigma. So here our x is 6.5, so 6.5 minus mu is 10 divided by sigma, which is 2, and this is 6.5 minus 10 and divided by 2, that is negative 1.75, negative 1.75, and the g for mean is always a 0. And let me just write down that here. So this is 6.5, this is 10, and our g for 6.5 is negative 1.75, and g for mean is 10. Okay, now we are interested in finding the area of this blue region. Okay, we know g for this point, which is negative 1.75. Let me take positive 1.75. So this is positive 1.75. Okay, this area, okay, the area from negative 1.75 and 0 is equals to the area from 0 to 1.75. Okay, our normal distribution is symmetrical, so the area under this curve, so that this green region and yellow region, they have exactly same area. Our g table gives the area, this g table gives the area of this green region. G table gives the area, which is a probability that our g takes a value, this is a 0, greater than 0 and less than 1.75. Okay, so the g table always gives the probability that g takes a value greater than 0 and less than this some positive number. Now let me go to g table and find this probability. So we have g equals to 1.75. So in normal table we look for 1.75, so 1.7. So we have 1.7 here and 5 is here, so the corresponding, so 1 point, okay, so 0.4599. okay, so 1.7 here and 0.05 here, so 0.4599. so this area is 0.4599. okay, let me double check. 0.4599, yes. Okay, this green and yellow, they are exactly same, so the yellow is also 0.4599. okay, now what we know next here is that the area on the left of this mean, okay, this area is always 0.5, and the area on the right of mean is always 0.5. We know this total area is 0.5. This red region is 0.5. Okay, our yellow region is 0.4599. So the blue region would be which is probability that x is less than equals to 6.5. This is the blue region, and this area is 0.5 minus 0.4599, and this is equals to 0.5 minus 0.4599, 0.0401. So this is the probability that our x takes a value less than equals to 6.5. Okay, next number D. So in number D, we are asked to find probability that our x is in between 5.34 and 13.4. It's very similar. We are still using the normal distribution. So let's start with a bell-shaped curve. Okay, you locate mean. Our mean is 10 here. Okay, let me double check. Yes, mean is 10. So this is now the next we locate these two number. So 5.34 is somewhere here, 13.4 is somewhere here. This horizontal is our x. Okay, normal distribution means always normal table, and to use normal table we need a g value instead of x. So let's go ahead and convert each x into g. So to convert 5.34, we have 5.34 minus mu, which is 10, divided by sigma, which is 2, and this is 5.34 minus 10 divided by 2, negative 2.33. So g for this point is negative 2.33. G for mean is always 0. Let's go ahead and convert 13.4. So 13.4 minus mean 10 divided by sigma 2. So 13.4 minus 10 divided by 2, we get 1.7. So the g for this point is 1.7. We are interested in finding the area between 5.34 and 13.4. So 5.34 is here, 13.4 is here. So we are interested in finding the area between 5.34 and 13.4, or we are interested in finding the area between negative 2.33 and 1.7. So which is these two area. So we are interested in finding this area. Okay, now at first our g for this point is 1.7. So we can find the area on this part of area using our g table. We look for 1.7, or we can also rewrite this as a 1.70. Now let me go to g table and look for the probability. So 1.7. So at first we locate 1.7. So 1.7 is here and 0 is here. So the corresponding is 0.4554. So this is 0.4554. Okay, now to find the area of this yellow region, very similar to the one that we did for part B, we find the area of this yellow region, and for that we look for 2.33 in the normal table. Okay, 2.33. So let's locate 2.3 first. So 2.3 is here. So 2.3 is here, and 33 is here. So the corresponding 0.4901. So this is 0.4901. Okay, so this yellow region is from this point, from negative 2.33 to 0. Now the probability that our x takes a value between 5.34 and 13.4 is the sum of these two area. So area of yellow region, which is 0.4901, and the area of green region, which is 0.4554, and this is equals to, so we have 0.4901 plus 0.4554, which is 0.9455. So this is the probability that our x is greater than equals to 5.34 and less than equals to 13.4. So this is part D. Okay, now the next here, so in number 5, so here we already have a standard normal random variable, so we use the G table and find the probability. So for part C, we want to find the probability that our G is less than 2. So you start by drawing a bell shaped. Okay, so our mean for standard normal random variable is always 0, so we locate 2. So let's say our 2 is somewhere here, and we want to find the area, or we want to find the probability that our G is less than 2. So G less than 2 mean everything on the left of 2. Okay, so this is what we want to find. We want to find the area of this green region, but what we know this area. Okay, the area on the left of 0, the total area on the left of 0 is already 0.5. This is 0.5. Okay, next, to find this area, so to find this area we use normal table. So this is the area from our G 0 to 2. So we look for 2 on our G table. So we go ahead and look for 2 in our G table. So 2 is 2.00, right? 2 is same as 2.00, so 2.00. So 0.4772. So this is 0.4772. So the area or the probability that G is less than 2 is 0.5 plus 0.4772, and this is equals to 0.5 plus 0.4772, 0.9772. So this is the probability that our G takes a value less than 2. Okay, in part D, we are asked to find probability that G is greater than 2. So in part D, we want to find probability that G is greater than 2. Now in the same distribution, let me use the same graph. So G greater than 2 means everything on the left of 2, right? So everything on the left of 2, and that will be equals to, so if we so the total area under this curve is 1, okay, and if we subtract this portion from this graph, we will get the area for the right part. Okay, so total area is 1 minus this circle area is 0 0.9772, and this is equals to 0 0.0228, or you can just use very similar method as we did for part C. So in part E, we are asked to find probability that our G is in between -2 and +2. So let me draw a bell-shaped curve at first. So this is number E. So in number E, we want to find probability that our G is greater than -2, less than +2. Yes. So you draw a bell-shaped curve. So we need a bell-shaped curve. Mean for standard normal distribution is 0. -2 is somewhere here, +2 is here, and we want to find the area from -2 to +2. So we are interested in finding these two area. Okay, so let me call this is area A1, this is area A2. Okay, area A1 is equals to area A2. Okay, this point is at -2, and this point is at +2. So the area has to be equals to each other. The graph is symmetrical. Now we can find the area A2 with the help of G table. Okay, so area A2 is, so this area, and we know what is this area from our part C, which is 0.4772. So you look at 2.00 on your G table, and you get the area of this part as 0.4772. Okay, area A1 will also be same, 0.4772. So the area for both of these two region is area A1 plus area A2, which is 0.4772 plus 0.4772, and this is equals to 0.4772 plus 0.4772, and which is 0.9544. So this is the probability that our G is in between -2 and +2. Okay, next in number F, we want to find the probability that our G is in between -1 and +1. So let me draw, okay, that's number F. Bell-shaped curve. Our mean is 0, this is -1, this is +1. We want to find this area. We want to find this area. So let me call this is area A1, this is area A2. Area A1 and area A2, both of them are exactly same. Okay, we find area A2 with the help of G table. Okay, so our G is from 0 to 1, so we look for G 1.00. So if we go back to our normal table, so 1.00, so 1.0 is here, 0 is here, so 0.3413 0.3413 is the area A2. Area A1 is also same because these two are equals to each other. Now the probability that our G is in between -1 and +1 is A1 plus A2. A1 is 0.3413 plus A2 is 0.3413, and the sum is equals to 0.6826. This is the area. In number G, we want to find probability that our G is in between -2.5, -2.5, sorry, -2.51 and 0.51. So you draw bell-shaped curve. Mean for a standard normal distribution is 0. Locate these two number. So let's say this is -2.51. 0.51 is, let's say, here, and we are interested in finding area from this point to this point. We are interested in finding the area of this green region. Let me call, so let's call this is area A1, this is area A2. Now we use the G table for area A1 and area A2. For area A2, we look for 0.51 in our G table, 0.51. So 0.5 is here, 1 is here, so 0.1950. So this is 0.1950. For area A1, we look for 2.51. So 2.51. 2.5 is here, 1 is here, so 0.4940. 0.4940. Okay, and this probability is A1 plus A2, so that is 0.4940 plus 0.1950, and this is, okay, so 0.4940 plus 0.1950, which is 0.689. So this is the probability that our G is in between these two numbers. Okay, the next one we have number H. Number H, okay, it's very similar. We want to find probability that our G is in between -4.8, sorry, 0.4.8 less than equals to 1.34. 1.34. So you draw bell-shaped curve. Okay, locate your mean 0. Locate these two number. I think this should be negative, right? Let me double check. Negative, yeah, negative 0.48. So this is negative 0.48. So let's say negative 0.48 is here, 1.34 is here, and we are interested in finding the area from negative 0.48 to 1.34. So we want to find this area. So let me draw a vertical line at 0. Let's call this part is A1, this part is A2. Now we use G table. For A2, we look for 1.34 in our normal table. So 1.34. So 1.3 first and 0.04. So 0.4099. So this is 0.4099. Now for the A1, A1 is from negative 0.48 to 0. Okay, so we take this positive 0.48 and use the normal table, 0.48, 0.4. So 0.4 is here and 8 is here. So this is 0.1844. So this is 0.1844, and sum of these two area is our answer. 0.1844 plus 0.4099, and this is equals to 0.1844 plus 0.4099. So our probability that G takes a number greater than equals to -48 and less than 1.34 is 0.5943. Okay, so this is for number 5. Now in number 6, we have a normally distributed random variable. Our mu is 29, sigma is 8, and we are asked to find value of x naught. So let me say for part C. So since this is a normal distribution, the first step is we draw bell-shaped curve, locate our mean. So our mean is 29. Okay, so we want to find x naught such that probability that x greater than that x naught is 0.10. Now here you should be able to locate your x naught correctly. Okay, so for example, let's say our x naught is on the left. Now what is given to us? The probability that x greater than x naught. So greater than x naught means everything on the right of x naught is 0.1. Is it possible? Does it make sense here? Now here it does not make sense because we know the area on the left of 29 is 0.5. Okay, so this part is already 0.5, and if you add this part we must get a number greater than 0.5, but here we have 0.1. So what it tells that our x naught is on the right side, okay, of 29. Let's say our x naught is here. Okay, and 0.1 is x greater than x naught. So our area on the right of x naught, so this area is 0.1. Okay, and this area would be 0.5 minus 0.1, which is 0.4. Now we use our G table, look for a number very close to 0.4. So let's go back to normal table, and here we look for a number very close to 0.4. Okay, 0.4. 0.4. Okay, so here we have 0.3997, and here we have 0.4015. So out of these two number, so this number is very close to 0.4. So the corresponding G value is 1.28. So 1.28 is the G value for this point. Okay, for this point. So G for this x naught is, so the G for this x naught is 1.28. Now this is our G, this is our x naught. So these two are not same number. Okay, but we know how to convert x into G. So the formula is x naught minus mu, our 29, divided by sigma, which is 8. And so this is a G for x naught, and this is also G for x naught. So these two number has to be equals to each other. Okay, so I use formula g equals to x minus mu divided by sigma. Okay, now let's simplify this. We multiply both side by 8. This 8 cancel. We have x naught minus 29 equals to 1.28 into 8, 10.24. Now we add 29 on a both side and we get the value of x naught, which is 39.24. So this is the x naught for part C. Now for part D, probability that x is greater than x naught is 0.95. Okay, so let me draw bell-shaped curve. Our mean 29. Now let's look at x naught. So where should be our x naught? So what we know, the probability that x taking a value greater than x naught is 0.95. Okay, so if you have your x naught like on the right side here, the probability on the right of x naught, will it be 0.95? Is not, right? Because we know the probability on the right of 29 is 0.5 and this cannot be 0.95. So our x naught has to be on the left side. So let's say here, and we are interested in finding x naught, and our probability is greater than x naught. So it means everything on the, sorry, this is, so everything on the right of x naught is 0.95. Okay, that's what is given to us. So all this area, probability is same as area. Okay, this area is 0.95. Okay, we know this area is 0.5, so the remaining area is 0.95 minus 0.5. We get 0.45. Now we look for the number close to 0.45 on the g table and they find corresponding g value. So 0.45. 0.45. So here 0.4505, 0.4495. These two numbers are at the same distance from 0.45. So we take the average for a g value for this number. So the g for this number is 1.64. 1.64. G for this number is 1.65. 1.65. We take the average, we add these two and divide by 2. So that is 1.64 plus 1.65 divided by 2. We get 1.645. So 1.645 is the G for this point. Now since this point is on the left side of our mean, it has to be negative. Okay, so the G for this point is negative 1.645. Let me double check that. Yes, 1.645. Okay, since our point, okay, since this x naught is on the left of mean, the G is negative. If you have your point on the right of mean, it's positive. Now next, let's convert this x naught into g, which is x naught minus mu 29 divided by sigma, which is 8. Let me double check. Yes, here this is the g for this point. This is also g for the same point. So these two number has to be equals to each other. Now we multiply both side by 8. This 8 cancel. We have negative 1.645 into 8. So that is negative 13.16 equals to x naught minus 29. We add 29 on a both side and we get x naught equals to 15.84. So our x naught is 15.84. Okay, so this is for number D. Okay, now in number 7C, so here I look for what type of distribution is this. Let's see. Okay, normally, now it does tell here we have normally distribution. So let me start with a bell-shaped curve. Then I need mean for this distribution. Mean is 105.3. So this is 105.3. Next we need is standard deviation. Standard deviation is 8. So mu is 105.3. Standard deviation is 8. And we are asked to find A such that probability that x taking less than A is 0.2. Now at first you have to locate your A correctly. Okay, our A, so let's take our A is here. So if our A is here, now x less than A means everything on the left of A. Now is everything on the left of A is 0.2? It's not, right? Because we know area on the left of left of 105.3 is already 0.5. This is already 0.5 and we can't have all this 0.2. Okay, so our A is not on the right side, it has to be on the left side. So let's say our A is here and the area on the left of A, okay, less than A means the area on the left of A is given to us as a 0.2. So this is 0.2. The total area on the left of 105.3 is 0.5. So this area is 0.5 minus 0.2, which is 0.3. Now we use the G table, look for a number close to 0.3 and that will give us the G for this point. So 0.3. So let's go ahead and look at 0.3. Okay, 29. So we have this number 0.2995 and these two numbers. So out of these two, this one is the closest. So the corresponding G is 0.84. And since our A is on the left of mu, so it has to be negative 0.84. So so negative 0.84. Now we convert A into G. So that is A, to convert A into G, that is A minus 105.3 divided by 8, and the G for the same point is negative 0.84. We multiply both sides by 8, this cancel, we have A minus 105.3 equals to okay, so here negative 0.84 times 80, okay, and that's negative 6.72. You add 105.3 on both sides and we get our A equals to 98.58. Okay, this is the final answer. It's very similar to the one that we did earlier. Okay, next here. Okay, number 10. In number 10, we have a population described by this probability distribution. Our x takes 4, 5, 6, 7. the probability that x takes 4 is 0 0.1, probability that x takes 5 is 0 0.2, probability that takes x6 is 0 0.4, and the probability that x takes a value 7 is 0 0.3. And here the random variable is observed twice, okay, and the probability is given. So we have to complete this table. So at first we find our mean, okay, mean of x values. So here the mean of 4 and 4 is 4 plus 4 8 divided by 2. The mean is 4. The mean of 4 and 5 is 4.5. Okay, so let me just write down here. Okay, so the mean x bar is 4. X bar for 4 and 5, 4.5. 4 and 4 plus 6, 10 divided by 2, 5. 4 plus 7, 11 divided by 2, 5.5. 5 plus 4, 9 divided by 2, 4.5. 5 plus 5, 10 divided by 2, 5. 5 plus 6, 11 divided by 2, that is 5.5. 5 plus 7, 12 divided by 2, 6. 6 plus 4, 10 divided by 2, that is 5. 6 plus 5, 11 divided by 2, 5.5. 6 plus 6 divided by 2, that's 6. 6 plus 7, 13 divided by 2, 6.5. 7 plus 4, 11 divided by 2, 5.5. 7 plus 5, 12 divided by 2, 6. 7 plus 6, 13 divided by 2, 13 divided by 2, 6.5. 7 plus 7, 14 divided by 2, 7. So our mean, the smallest mean is 4. Then we have 4.5, we have 5, then we do have a 5.5, and then we have 6, 6.5, and 7. Now we find the probability that our x bar is 4.5. So where do we have 4.5? So here 4.5, 4.5, yeah, that's those two. So you add 0. So you add this probability and this probability, which we get 0 0.04. So to find the probability of x bar is 5. Oh, so this is 4.5, this is 5, this is 5.5, this is 4.5, this is 5. So for 5, let's look for the 5. So 5 is here and 5 is here, 5 is here, right? So let's add the corresponding probability. 0.04 plus 0.04, 0.08 plus 0.04, 0.12, 0.12. Now for 6.5, so let's look for 6.5. So we have 6.5 here, 6.5 here. So you add the corresponding probability, 0.12 plus 0.12, 0.24. Now we look for the 7. Our 7 is here, sorry, seven is here, so 0.09. Now in this table, if you add all this probability, the sum has to be equals to 1, okay? So 0.01 plus 0.04, 0.05 plus 0.12, 0.17. Let me add 0.17 plus 0.22, 0.39 plus 0.28, 0.67 plus 0.24, 0.91 plus 0.09, we get 0.91 plus 0.09, we get 1, okay? That's how you can also check whether your table is correct or not. Next we have to construct a probability histogram for this table, okay? So we need a horizontal line, which is our x bar. So this is x bar, and this is our probability of x bar. So our x bar is 4, so this is 4, 4.5, 5, 5.5, then 6, 6.5, 7. Like a histogram, the probability is the height of a bar. Okay, so let's say this is okay, so here okay, so let's have a scale. So this is 0.1, this is 0.2, and this is 0.3. So 0.01. So when our x bar is 4, the probability is 0.01. So 0.01 is here. So we draw a bar of height 0.01. 4.5, 0.04. So 0.4. It looks a little taller, right? So 0.01. Okay. 0.04. This is 0.5. This is 0.15. This is 0.25. So 0.04. Sorry, this is 0.0. 4 is slightly below 0.05. The probability when our x bar is 5 is 0.12. So 0.12 is somewhere here. Five point five, 0.22. So the bar height of a bar is 0.22. 6, 0.28, close to 0.3. 6.5, 0.24, greater than 0.22, right? 7, 0.09. This is close to 0.1, smaller than this one. Okay, this is the bar graph. So 0.01, 0.04, 0.12, 0.22, 0.28, 0.24, 0.09. Okay, next we are asked to find the probability in part C, probability that x bar is 6 or larger. It means greater than or 6. So our x bar equals to 6 or greater than 6 means x bar 6, 6.5, 7. So we are interested in when our x bar is 6, when x bar is 6.5, and when x bar is 7. So you add the corresponding probability. So this is 0.28 plus 0.24 plus 0.09, and this is 0.28 plus 0.24 plus 0.09, 0.61. Okay, next here our sample size is 25, and we have to find the mu and sigma. Okay, no, mu and sigma is given, and we have to find mu of x bar and sigma of x bar. Okay, So using our, okay, what we call that rule, let me double check. Okay, so the central limit theorem. Yes, so according to central limit theorem, our mu of x bar is equals to mu, so which is 169. This is part B. And sigma of x bar is sigma over square root of n. So sigma is 25, square root n is 25. So this is 25, square root of 25 is 5, which is 5. Similar way for C, our mu of x bar is equals to mu, which is 26. Sigma of x bar is sigma divided by square root of n. So sigma is 45 divided by square root of 25. This is 45 divided by 5, which is 9. For D, mu of x bar is equals to mu, which is 13, and sigma of x bar is sigma divided by square root of n. Sigma is 100 divided by square root of n is 25. 100, this is 5, and 20 is the sigma of x bar. Okay, number 12, our n is 100, mu is 29, sigma is 23. We have to complete this. So mu of x bar is equals to mu, which is 29. Sigma of x bar is same formula, sigma divided by square root of n. Sigma is 23, square root of n is 100. So this is 23 divided by 10, 2.3. Describe the shape of sampling distribution of x bar. Okay, our mu is 29. We need to describe the shape of sampling distribution of x bar. Okay, so we use our central limit theorem here. Our n is sufficiently large, okay, so which is 100. So when we have sufficiently large sample size, then the sampling distribution of x bar, the sampling distribution, the shape of sampling distribution of x bar is always approximately normal. Now, since our sampling distribution of x bar is normal, to find C, D, E, F, we use a normal distribution. So we need a bell-shaped curve. Okay, now make sure we are finding for C, we are looking, or we are trying to find probability that our x bar is greater than equals to 28. Okay, our x bar, and this x bar has a normal distribution, and because of that we are drawing this bell-shaped curve. So the mean for that distribution is 29. So we have 29 here. Now let's locate 28. So 28 is here, and we are interested in finding the area, finding the probability that x bar is greater than 28. Greater than 28 means everything on the right of 28. So this is our 28. So we want to find the area on the right of 28. Okay, the total area on the right of 28. We know the area on the right of 29. 29 is the mean, so the total area on the right of mean is always 0.5. So this is 0.5. Now if we can find this area, the sum of these two area will be our answer. Okay, now here this is our x bar. Okay, it's a normal distribution. We use a g table, but to use a g table we need to convert each x bar into a g. Okay, for that, to convert 28 into G, the formula is 28 minus mu 29 divided by sigma of x bar. Okay, not sigma. So the formula here would be x bar minus mu of x bar divided by sigma of x bar. Okay, do not use the mu of this sigma, do not use this mu. You are using mu of x bar, which is 29, and a sigma of x bar, which is 2.3. So this is 2.3 here, and this is -1 divided by 2.3, negative 0.435. Okay, now we use our G table, look for 0.435 and get the area 0.435. Okay, 0.4 is here. Okay, we do not have so we just have a 2-digit, right? So let me just round off that number. So let me rewrite this 0.435 as a 0.44, negative 0.44. So we look for 0.44. 0.4 is here, 0.4 is here, 0.4 is 0.04 is here. So the corresponding 0.1700, 0.17. So this area is 0.1700. So the total area would be 0.177, sorry, 0.1700 plus 0.5, which is 0.67. That's for part C. In part D, we want to find our P such that x bar is in between these two numbers. So let me draw bell-shaped curve. Our mu of x bar is 29. So this is 29. And we want to find probability that x bar is greater than equals to 22.1, less than equals to 26.8. So let's locate these two numbers. Let's say 22.1 is here, 26.88 is here. We are interested in finding the area from 22.1 to 26.8. So we are interested in finding this area. This is a normal distribution. We use a G table. Okay, let me draw a vertical line at 29. So you convert each of these x bar into G like we did earlier. So for 22.1 minus mu of x bar 29 divided by sigma of x bar 2.3, and this is, so 22.1 minus 29 divided by 2.3, that's negative 3.00. So G for 29 is always 0. For 26.8 minus 29 divided by 3, 26.8. Sorry, okay, now here, okay, this is, okay, my bad. 26.8 has to be on the left of 29. Okay, it's not on the right side. So this is my mistake, because 26.8 is smaller than 29. So here, this is our 26.8. So we are interested in finding this area. Okay, but still we need to convert that 26.8 into G. For that, 26.8 minus 29 divided by 3. 26.8 minus 29 divided by 3. So that is G for that point is negative 0.73. Okay, now our target is finding the area of this green region. So we know the G for this point is negative 3.0, G for this point is negative 0.73. Now this is our mean. So we can find, so using this G value we find the area of this region. Okay, it gives the area of this part, and the area would be from G table. We look for the 3.0. So 3.3.0, 0.4987, 0.4987 is that black shaded, the area for the black shaded part. Okay, now using 0.273, which is the G for 26.8, we can find the area of this yellow region. 0.73 is here. So 0.73, 0.2673, 0.2673, and our target is finding the area of green region, right, which is the difference of 0.4987 minus 0.2673, and the difference is 0.4987 minus 0.2673, 0.2314. So this is for part D. Now for part E, we want to find probability that our X bar is less than equals to 28.2. So start from a bell-shaped curve. Mu of X bar is 20, still 29. We locate 28.2. So 28.2 is here. And less than means everything on the left. So we want to find the area of this part. Okay, we know this total area is 0.5. Now convert this into G. So 28.2 minus 29 divided by sigma of X bar 2.3. So that is 28.2 minus 29 divided by 3. We get negative 0.27. So the G for this point is negative 0.27, and using G value, so you look for the 0.27 on your G table, and that will gives the area of this region, okay, of this green region from mean to that G value. So 0.27. So 0.27, 0.2 is here, 7 is here. So 0.1064. So this green region is 0.1064. So the area of yellow region will be difference of 0.5 minus 0.1064. So 0.5 minus 0.1064 is 0.3936. Okay, this is E. In number F, 27. Okay, in number F, we are asked to find probability that x bar is greater than equals to 27. Let me double check that. Greater than 27, yes. It's very similar. Draw bell shaped. 29 is mu. Locate 27. 27 is here. So greater means everything, we want to find everything on the right of 27. That's what we need to find here. We know this area, we already know the area of this part, 0.5. Now let's go ahead and find the area of this part. For that we convert this into g. So 27 minus 29 divided by 2.3. Okay, here 27 minus 29 divided by 2.3, so we get negative 0.87. so the g for this point is negative 0.87. so use the g table, look for 0.87, that will give the area of this part. Okay, so 0.87, 0.87 is here, so 0.3078. so this is 0.3078. let me double check. 3078, yes. Okay, so the total area would be 0.3078 plus 0.5, which is 0.8078. Okay, this is number F. Now in number 13, so our mu is 320, sigma is 80, our n is 100. We use central limit theorem. Using central limit theorem, mu of x bar is equals to mu, which is 320. Sigma of x bar is sigma divided by square root of n. Sigma is 80, n is 100, so 80 divided by 10, so 8. Using that central limit theorem, the sampling distribution of x bar is approximately normal. So we are asked to find the probability that the mean, okay, not, so make sure probability that mean. So in part B, we are asked to find probability that our mean x bar is between, so is between 300 and 310. Okay, since we know our distribution is normal distribution, let's draw bell shaped. Our mu of x bar is 320, so 320. Let's locate these two numbers. 300 is here, 310 is here, and we want to find the area between 310 and 300, sorry, in between 300 and 310. Okay, So let's convert, this is x bar, so let's convert each x bar into g. So for 300 minus 320 divided by sigma of x bar, which is 8. Do not use 100, okay, 8. So we have 300 minus 320 divided by 8, and this is negative 2.5. We convert 310, 310 minus 320 divided by 8, and negative 1.25. Now we use the g table. If you take 2.5, it gives the area, it gives this area, okay, from 300 to 320. So 2.5, 2.5, 2.50, which is same as, okay, 0.4938, 0.4938. So 0.4938, let me double check, 0.493. okay. Now using this g, we get this area, okay, 1.25, 1.2, and 5 is here, 0.3944. So this green is 0.3944, 0.3944, yes. And the difference is the probability, so 0.4938 minus 0.3944, and the difference is 0.4938 minus 0.3944, 0.0994 is the final answer. Okay, next we want to find probability that x bar is greater than 365. Okay, draw with a bell shape, locate mu, that is 320. We want to find probability that x bar is greater than equals to 365. So let's locate 365. Let's say it's here. So greater than means everything on the right of 365. So we are interested in finding this part. At first we convert, we know this black shaded region is 0.5. Now we convert into g. So 365 minus 320 divided by 8. So 365 minus 320 divided by 8, 5.63. Okay, now we use 5.63. That is so if we go back to a normal table, so we don't have 5.63 here, right? So what does that mean? So let me double check here. 365 is here, and so 365 minus 320 divided by 8, 5.63. 365 divided by 8, that's 8 is ours. 8 is the, yes, 320, yes. So we have a very small area, okay. So if we check the area for the g with the 3, then our 3.009 has a area like 0.4990, so which is close to 0.5, right? So uh, this area is almost 0.00, so this area is almost 0.5. Okay, and our target is finding the area of green regions, which is the difference of 0.05, and this is closely 0.00. Okay, the probability that x bar is greater than equals to 365 is almost 0.